Today we're going to talk about Workbook 4A, Exercise 9. In the textbook, turn to page 21, where we have some more questions about factors. Number 5 asks us a question, is 3 a factor of 21? Well, there's two ways you can think about this. Both of them are fine. If you actually did 21 and think about 21 divided by 3, and realize that 3 goes into 21 7 times and it goes evenly, so there's no remainder, then that tells you, yes, 3 is a factor of 21. 21 can be divided by 3 exactly, so 3 is a factor. It's also maybe even easier to think of it as, since 3 times 7 equals 21, it is a factor. What about part B? Is 3 a factor of 26? Well, if we did that division problem, the closest I can get to 26 is 8. 8 times 3 is 24. When I subtract, I get 2. So the answer to that division problem is 8, remainder 2. That tells us, since there's a remainder, that it is not a factor. I could also think, counting by 3's, I can get to 24, and I can get to 27, but I cannot get to 26. So both of those methods tell me that 26 is not a factor, 3 is not a factor of 26. Look at number 6. The question is 2 a factor of 98? Well, that one I can tell you really quickly because it's an even number. We talked about even and odd in a previous primary math level. Since it's even, it divides by 2 evenly. So therefore, 2 is a factor of 98. Now let's say that you'd forgotten that, and we're actually going to talk more about that in coming days, but you can do 98 divided by 2. You can do the long division. 2 goes into 9 4 times. 4 times 2 is 8. Subtract and get 1 and bring down the 8. 2 goes into 18 9 times. 9 times 2 is 18. Subtract and get 0. Because you have numbers that go into 98 equally, 2 is a factor of 98. What about is 4 a factor of 98? Well, what we've just found is that 98 divides into 2 parts evenly. Each of the parts, according to what we found up here, is 49. Can I divide those evenly and so that I have 4 parts? Well, the answer to that is no. 49 divided by 2 is not even. That's going to end up with a remainder. So is 4 a factor of 98? No, 4 is not a factor of 98. Now again, it's always good to think about math, but also to be able to do the math. You can know for sure that 4 is not a factor when I do 98 divided by 4 because a factor will go in evenly. 4 goes into 9 twice. 2 times 4 is 8. Subtract, bring down the 8. 4 goes into 18 4 times. 4 times 4 is 16. Subtract and get 2. So 24 remainder 2 is the answer. That tells me for sure that 4 is not a factor of 98. Are you beginning to fully understand what a factor is? Number 7 asks, is 4 a factor of 60? There's a couple of ways you could do it. 60 divided by 4, that's a perfectly good way to do it. I could think of 4 times something gives me 60. Remember when we talk about multiplying by 4, we say we double it? So if 60, if I take half of it, I'm at 30. Take half of that, I'm at 15. So 4 times 15 is 60. 60 divided by 4 is going to be 15, so yes, 4 is a factor of 60. Is 4 a factor of 84? Well, that's an easy one. Think about 84 divided by 4. If I have 8 tens divided by 4, I have 2 tens. If I have 4 ones divided by 4, I have 1. So 4 is a factor of 84. Then it asks a new question with a little bit of a new phrase. Is 4 a common factor of 60 and 84? In other words, is it a factor that they have in common? You know what that means, right? Maybe you have in common with your sibling that you both have brown hair, or maybe you have in common the fact that you both have blue eyes. If it's something is in common, they both have it. So 4 is a factor of 60 and 4 is a factor of 84. So yes, 4 is a common factor of both of those numbers. So then look how it continues to stretch you and make you think. Is 5 a common factor of 75 and 80? Well, is 5 a factor of 75? Yes. Remember we talked about numbers that end in 5 or 0? If you count by fives, 5, 10, 15, 20, every number that ends in a 5 or a 0 is it has 5 as a factor. So 5 is a common factor because 5 is a factor of each of those numbers. Is 8 a common factor of 72 and 96? Do you see that they ask one question and then we have a lot of work to do? Again, if you remember the way you can count by eights, since 8 times a number is 72 and that number is 9, you can also think of it as a division problem. Think about 96 divided by 8. Remember when we've done division this way? 96 is 80 and 16. If I divide by 8, I get 12 is that answer I'm looking for. 80 divided by 8 is 10. 16 divided by 8 is 2. So 8 times 12 is 96, since I just found that 96 divided by 8 is 12. So 8 is a common factor of both of them. In order to know that, I need to know that 8 times something will give me that number. And whether you do it as a multiplication problem or a division problem, it works the same. Number 9 asks you to find the missing factors. 28 has factors of 7 and 4. Now that's not all of the factors, but the one that's missing according to the way they wrote this is 4. 40 is equal to 5 times 8. 72 is equal to 8 times 9. Do you see, if you know the multiplication numbers, this is very quick. If you're still struggling with those, you really need to go back and work on them. We've practiced and practiced and practiced. If you need more practice, you can make some flashcards. You can do some things to learn. 63 is 9 times 7. 56 is 7 times 8. These are all good things to know when you're working on factors. Now look at page 22. We're supposed to just find the factors of 32. To find the factors, I always think about all the multiplication problems that are possible. Again, start with 1. 1 times 32. 2 is going to work. It'll be 2 times 16. You might need to think of 32 as 20 and 12. 3 isn't going to work. If I count by threes, I get to 30, 27, 30, 33. Since 32 is not a count by 3 number, it's not going to be a factor. 3 will not be a factor of 32. What about 4? I tried 3. 3 didn't work. I could do 4. Remember, 4 If you multiply something by 4, you double it. So I'm going to take 32 and divide it in half. That's 16. Divide it in half again. That's 8. I think about 5. 5 is not a factor. I tried 3, by the way. 3 didn't work. 5 isn't going to work. 6 isn't going to work. 7 isn't going to work. And I'm already up to 8. So I know that I've tried everything I need to try. And my answers are going to be 1, 2, 4, 8, 16, and 32. You don't have to write it in the brackets. I just happen to write it that way. Those are the factors of 32. Can you pause and find the factors of 48 and the factors of 100 and then see if you get the same answers that I do? I'll go ahead and work it. Pause and work it on your own if you can. There are a lot of factors of 48, and you might have to do each of these individually. Think of 48 divided by 3. Think of it as 30 and 18. Think of that as 10 and 6. When I think about 4 as a factor, 48, if I divide that by 4, I'm going to have 1 10 and 2 1s. I know that 5 doesn't work because it doesn't end in a 0 or a 5. 6 will work. 6 times 8 is 48. 7 doesn't work. How do I know if 7 works or not? I know that 6 times 7 is 42. 7 times 7 is 49. There's not a number multiplied by 7 that's a factor of 48. After I find that 7 doesn't work, since I already have a solution for 8, I know that I'm finished. I can stop. And the factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. Each of those factors comes as a pair. 1 is paired with 48, 2 is paired with 24, and each of those numbers, all by themselves, are factors of 48. Let's look at 100. 100 is 1 times 100. It is 2 times 50. 3 won't go into it. If I did 100 divided by 3, I'd get a remainder. I know 4 works, 4 times 25. I know 5 times 20 will work. And you might have to do the math, but 6, 7, 8, and 9 do not work. But 10 times 10 is 100, and I know I'm finished because I've reached the same number twice. So the factors of 100 are 1 and 2, 4, 5, 10, 20, 25, 50, 100. Notice the only ones I had to actually try and do the work on were 1 through 10. Once I got to a number that repeated, I already knew that 10 was a factor, and it's 10 times 10, I'm through. Back in the other one, 6 times 8, once I've got to the point of trying 8, and I know that it works because it's a factor, so then I know that I'm finished. So then, number 13 gives us some practice, before we quit doing factors, of finding them. Again, great time to pause, try it on your own, see if you get all the factors. 40, of course, is 1 times 40, 2 times 20, 3 doesn't work, 4 times 10 works, 5 times 8 works, 6 and 7 do not work, and now I'm back to 8. So the factors are 1, 2, 4, 5, 8, 10, 20, 40. Those are all of the factors of 40. How about 50? Well, for 50, we have 1 times 50, 2 times 25, 3 doesn't work, 4 doesn't work, 5 times 10, 6, 7, 8, and 9, if you work on those numbers, none of them work. Since I'm back to 10, I know the factors are 1 and 2, 5, 10, 25, and 50. Those are all of the factors of 50. Notice there are more factors of 40 than there are of 50. And there's really no shortcut. You just have to do the work each time. 75 is 1 times 75. 2 is not going to work. 3 times 25. 4 is not going to work. 5 times 15. 6 will not work. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10 doesn't work. 11, 12, 13, 14. None of those works. But 15 I already know works. And so the factors are 1, 3, 5, 15, 25, 75. Those are the factors of 75. The last one is 80. 1 times 80, 2 times 40, 3 won't work, but 4 times 20, 5 times 16, 6 doesn't work, 7 doesn't work, 8 times 10, 9 doesn't work, and I'm repeating 10 again now, so I'm through. So the factors include 1, 2, 4, 5, 8, 10, 16, 20, 40, and 80. Lots of factors of some numbers, very few factors of other numbers. All right, with all of that practice, you're ready to do exercise 9. We're just finding factors and common factors of numbers so you can practice that skill.